Hello students, this is lecture 48. We discuss the initial values. Before that, we need to differentiate two concepts, that is zero positive and zero negative. We suppose the circuit is switched at time 0 in the following discussion. Then we can define that zero negative is the moment before switching, and zero positive is the moment after switching. That is to say, arbitrarily divide the point 0 into a period. Then for such a waveform, we can define that zero negative is the limit function value to time 0 approaching from negative side, and the zero positive is the limit function value to the time 0 approaching from positive side. It is obvious that for such a continuous waveform, we know that f0 negative is equal to f0 positive. But in circuits, it's not necessary for f0 negative must be equal to f0 positive. In lecture 46, we discussed the current in the capacitor. It might be such a waveform. Suppose this is some current form, and also suppose this value is 1 ampere. Then we know that I0 negative is 0, and I0 positive is 1, not equal to I0 negative. In this lecture, we need to find out the zero positive values for all interested branch variables. Note again, zero positive value might be different from zero negative value. Now we discuss a law called the switching law, which is about what happens during switching. The switching law has two parts. The first one is about capacitors. The integral form of UI relationship of capacitors is like this. In this equation, we intended to rewrite the 0 as 0 negative and all the t as 0 positive. So the equation can express the UC change from 0 negative to 0 positive, a very small period. Let's see this item. Let's see this atom. If the capacitor current has a jump, like we discussed previously, no matter how high it is, the integral value from 0 negative to 0 positive is 0. That is, if I value is not infinite, the integral value from 0 negative to 0 positive is 0. So UC0 positive is equal to UC0 negative. The condition is that IC is not infinite during 0 negative to 0 positive. Of course, UC0 positive is equal to UC0 negative means that QC0 positive is equal to QC0 negative. So we prove the charge conservation in another way. After capacitors, by using dual concept, we can find the switching law for inductors. If the inductor value voltage during 0 negative to 0 positive is not infinite, this value is 0. So IL0 positive is always equal to IL0 negative. Then the corresponding magnetic flux linkage conservation means that psi L0 positive equal to psi L0 negative. Before the following contents, we need to further discuss that UC0 positive is equal to UC0 negative. Please see that the capacitor voltage keeps unchanged during switching. Then we can use a voltage source with value UC0 negative to substitute the capacitor during the switching. Similarly, the inductor current keeps unchanged during switching. So we can use a current source with the value IL0 negative to substitute the inductor during the switch. With substitution, you will see that it's easy to find the zero positive value for any branch variable.